In this video, we are going to do these three questions from the chapter Vector, right, for our class 12th. Let's begin with the first one. So in this question, it says that vector A is this, vector B is this, and this vector C as well. And they are such that A plus lambda B, that means A plus lambda B is perpendicular to the vector C, right? So we have to find the value of lambda. So what we know that when two vectors are perpendiculars, their dot product is zero, right? That's what we know. When two vectors are perpendicular, their dot products are zero. So that means we can say that A plus lambda B should give you zero, right? As you know that these two vectors are given perpendicular. Now check what we can do if I plug in the values of this vector. Let's say if I plug in the value of this vector. So what I did, I replaced A with the vector given here. As you can see over here, the vector A is mentioned, vector V. So I just plug in the value. Now what we are going to do is to simplify this. I can see that if I write them in the standard form, this is 2 minus I. So let's begin writing that only. This is 2 minus lambda times I plus 2 plus 2 times lambda j cap, and finally it's 3 plus that's k, that is lambda times k, right? This is what on simplification, and it's dot product with the other vector, which is 3i plus j cap, right? That is equal to 0 given. So if their dot products are 0, now I'm going to do is what? Next, I'm going to multiply their direction ratios, or you can see their scalar component. That means 2 minus lambda multiplied by 3 plus this multiplied by, this is what, j, yeah, j. So this is 2 plus 2 lambda times j component is 1 is equal to 0. Now I did not write the I component. As you can see, I component over here is 0. Now if I simplify, this is going to be what? 6 minus 3 lambda plus 2 lambda should result to give you 0. Now this is 6 plus 2, 8 minus 2, 3 plus, yeah, this is negative 3 and this is positive 2. So it will give you negative lambda. That means lambda comes out to be 8. I think this is what we have to find out, the value of lambda. And that's how we'll do this question. Now in this question, it says A and B are two vectors such that A magnitude is 2, B magnitude is 1, and we are given A dot B as equal to 1. And what we have to get is the dot product of these two vectors. Now check if I show you the working involved in doing this question. The first thing that we have to get is the product of these two. So I'll write over here. Now, next is the working of this. That's a multiplication. We know that 3 into 2 is 6, and A dot A likewise minus 5, or we may write 3 multiplied by 7 is 21. A dot B minus 7B multiplied by 7 is, sorry, minus 7 into 2 is minus 10. And finally, we have minus 5 into 7 is minus 35B. Next, we are going to use the property that A dot B is A magnitudes whole square and B dot B is B magnitude whole square. The next thing that you should remember that dot is scalar in, commutative in nature. So A dot B is same as B dot A. That's why it results to give you 21 minus 10, that is 11 A dot B. So if you now in the next step, we can just plug in the value of A magnitude, which was given as 2, and B magnitude as 1. So it results to give you how much? 24 plus 11 minus 35. And that adds up to give 0. So this is how we will do this. In this question, it says we have a vector A as this, B as this, and C as this. We have to find a vector P. The vector P is what we have to get. This vector P we have to get, which is perpendicular to both vector. That means both P is perpendicular to A and P perpendicular to B. Further, P dot C is also given as 18. So let's consider the vector P first. We are going to take the vector P. First of all, let's say if I take vector P as this, I've taken vector P as this. Now what you can see that the vector P is perpendicular to vector A. So its dot product is going to be 0. So we'll write its dot product. That is, we will be writing the dot product, which is P dot A, right? P dot A is equal to 0. So that means we are just going to plug in P as this and A as this, and right, finding their scalar product, we obtain this equation. That's very clear, right? That is x multiplied by 1, y multiplied by 4, and z multiplied with 7 will give you this. Now we have one more information, that is even P dot B is going to be 0 over here. So if I write P dot B, so P dot B is going to be this, that is P vector, which is this, and B vector is this. I have written its dot product, further finding the product, which is here x multiplied by 3, x with 3, that is 3x, y with minus 2y, and so z plus z into 7 will results to give you this. Now we have obtained two relations here, and the third relation can be obtained from this, that is P dot C is given as how much? 18. So this is what we are going to apply over P dot C, right? So P dot C is what? This is P dot C. So P, as usual, we have taken P from this, and the C vector, which you can see was given here. So their dot product is same way as we have done the previous two part. Now we are going to simplify these three equations, 1, 2, and 3 to get the value of x. Once we obtain x, we are going to plug in the value of x, y, z over here to get it. Now to do, so we are going to solve these three linear equations of three variables. Now what I'll do here, I can see that if I multiplied 3 from this and subtract from this, we'll be able to get rid of x. So this is what I'll do. I'll multiply with 3 and say 1 with this. So the first equation will turn out to be 3x plus 4 into 3, that is 12y plus 6z is equal to 0. And now I'm going to subtract. This is minus 2y plus 7z equals 0. So for subtraction, we'll be altering their sign. And if I subtract them, this get cancelled. This is how much? 14y. And this is how much? Minus, yeah, that's 6 minus 7 is minus z is equal to 0. Now, same way we can solve other two equations. Let's say if I solve any other two, I say first with third, right? So here we'll multiply, equating the coefficient over here, multiplying this by 2 and this by 1. So this equation will result to give you how much? This is 2x plus 4y plus 2z equals 0. Oh, I multiplied with 2, right? I'm multiplying with 2, so it's going to be 8, right? And this is 4z. And over here, this is 2x minus y plus 4z is equal to 18. So we'll be subtracting, say this is minus plus and this is minus. So altering their sign, what do we see that here this get cancelled, right? So what we are getting over here, this is 9y, and this also get cancelled over here, and that is equal to minus 18. That results to give you y as minus 2. So we got the value of y, and I can see that if I replace y here with what? Minus 2. So it should give you minus 28 minus z equals 0, or we can write z on the other side, so positive z. So we got the value of z as well. Now once we got the value of x and y, we can place the value of x, y, x and z over here to get the other one. So let's say x be x and y, this is 4 times y and y is minus 2. So it will give you minus 4 into 2, that is minus 8. So this is minus 8 plus 2 times z, and z is how much? Z is again minus that is 56 minus 56 equals 0. So x comes out to be positive 64. So once we got the value of x, y, z, and then we are going to simply plug in the value of x, y, z in this. So that will give us the vector p. So check here, this is vector p as what? X, which is 64, I plus y, which is minus 2. So it's going to be minus 2 j cap plus z, which is minus 28 k cap. So this is minus 28 k cap. So we'll say that this is the answer for this question.